Hello students. Today our problem is to write a program to reverse the order of elements of a given array of numbers. For example, if the elements of an array are arranged in this order 2, 5, 6, 4, 8, 9, after the program executes, the elements should be arranged in its reverse order. That is 9, 8, 4, 6, 5, 2. That is what we want. In the same array, so the array is given, and in the same array the order should be reversed. 9 should become its first element, then second element should be 8, third element should become 4, fourth element should become 6, fifth element should become 5, and the last element should become 2. This is the way the elements of the original array should be arranged, that is in its reverse order. So for that we would be looking at two kind of solutions. One solution is the one in which we would be taking a separate array of same size as the original array, and using that second array we would accomplish this task. And the second solution that we would look at is a solution in which no extra array would be required. By using few handful of constant number of variables, we would be able to reverse the order of elements of the original array. So first of all, let us try the solution in which we need an extra array of same size as the original one. So uh, so let's say this is our original array. Three, 4, 9, 1, 6, 7. Right, I have taken examples of only even number of elements, but it is this solution would be very generic. Any number of elements, whether it is even number or odd number of elements, this solution would work there. So say the given array is this 3, 4, 9, 1, 6, 7 are the elements of the array. Now in the first solution, what we would do is we would take an extra array of same size as the original array. So we would take an empty array. So this is the given array. Let us name it as ARR1, and this is an extra array. Let us name it as ARR2. Now what we are going to do is, by using this extra array of the same size, so this is of the same size. So if the original array is of size 6, then this extra array would also need to be of size 6. 1, 2, 3, 4, 5, 6. Right. Now our task would be first to copy the elements of the original array to this new array in reverse order. So 7 should be first copied to this position, then 6 should be copied to this position, 1 should be copied to this position, 9 should be copied to this position, 4 should be copied to second last position, and the first element of the original array should be copied to last position. Right. So this would be our first step in the solution where we are taking extra array. So this would be our first step. So let us name it as step A. And then second step would be to copy these elements uh, that we have just now filled in the extra array back to the original array in the same order as they are in the new array. So 7 would be copied to the first position of the original array. 6 would be copied back to the second position of the original array. 1 would be copied back to third position of the original array, so on and so forth. So all the elements would be copied back to the original array, and thereby we would get the order of elements of the original array placed in its reverse order. Fine. So copy the elements back into the original array So these are the two steps that we need to follow in this solution. So first of all, we would go ahead and write the code for this solution, and then we would go for the second solution in which it would be optimized. That is, there would be no need of an extra array of the same size as the original array. Only handful of variables would be able to we would be able to accomplish the same task. All right, okay, let's go for writing the code. Now original array is this one, 2 5 6 4 8 9. This is given, and you take an extra array and let us name it as new ARR, and the size should be declared as same as the original array. So in this case the original array has 6 elements, so the size of the original array is 6. So the new array in which we would copy the elements in reverse order should also be of size 6. Now for copying the elements from the original array to the new array, we would be using a loop, right? Because this is a repetitive task, we need to copy one element at one time to the new array, and likewise every element should be copied one by one to the new array. So this is a repetitive task, and for that we would be using a loop. So let us declare a loop variable, and we would declare a for loop. So n elements are to be copied, right? So here n is 6, so 6 elements are to be copied. That's why the loop would run for 6 times. So it start with say 0 and I less than equals to 5. So we need to run this loop for 6 times. So initializing with 0 and finishing at 5 would let this loop run for 6 times, right? Now see here the sixth element, that is ARR1 5, ARR1 5. So this index is fifth index, right? Now fifth index of ARR1, the element at fifth index of ARR1 has to be copied to 0th element of ARR2. The fourth element of ARR1 has to be copied to position 1 of the new array. The third element, so the position 3 has to be copied to position 2 of the new element. So what is the relation here? So what is the relation of the position from which we are copying an element to the position in which we are copying the element? So what is the relation between these two positions? So when the position is 5, that is of the original array's position is 5, that is getting copied to 0th position of the new array. When position is 4, position 4 of the original array is getting copied to position 1 of the new array. Similarly, 3 is getting copied to 2, element at position 2 is getting copied to element into position 3 of the new array. Position 1 is getting copied to position 4, and position 0 is getting copied to position 5. So what is the relation? So if we consider this position, so if we consider this position, so these position if we consider as I, then the relation, so if I is 0 1 2 3 4 5, the relation of this this positions to I is given by 5 minus I. So when I is 0, 5 minus I is 5, because I is 0, 5 minus 0 is 5. When I is 1, 5 minus 1 is 4. When I is 2, 5 minus 2 is 3. So we have seen that this is the relation between the positions of the new array and the position of the original array. So now let us implement it. So this I actually is representing position of the new array, right? So new array I, in that we want to copy the 5 minus ith position of the original array. So original array here is given by ARR, and we want to copy the 5 minus ith position to of the original array to ith position of the new array. So this would accomplish the task of copying the elements of the original array to the new array in reverse order. Now after that, so with that we have accomplished the step A. Now after that, the step B is copy the elements back into the original array in the same order as they are in the new array. So for that we would need another loop which would iterate for n times. For in this case it would iterate for 6 times. Now it is simple that the position I of the original array would get the element at position I of new array. So it is simply to copy back the elements of the new array to the original array. So with this two loops we would be able to accomplish the task of reversing the order of elements of the original array. Right, now what we can do is we can just print the elements of the original array on the console and can check whether actually they have got reversed or not, right? So for that what we can do is we can just print these elements here. So we are copying back, we are copying the elements back to the original array, and apart from that we are also printing it on the console to see if the order is correct or not. So we print ith position of ARR, that is original array. Let's put a space here. Okay. Let us build it and run it. So build is successful. Now let us run it. 984652. So 984652. So we have accomplished our task by using an extra array of size n. So if you are aware of space complexity and time complexity, this solution is actually taking an space complexity of n, right? It is taking as many number of uh, extra locations as there are number of elements in the original array. So the space complexity of this solution is order of n. Now we want to reduce the space complexity to order of 1, that is only a few handful constant number of variables are allowed to be taken, and let us see whether we can accomplish that as well or not. So let us go for the second solution. So our second solution would be, so first I'll clear this out. Again, let me take an array. Some arbitrary array. So 9, 6, 5, 1, 3, 4, 2. So now the number of elements in this, or in this array, given array, is 7. Now we want to accomplish the task of reversing the order of elements of this array um, in place. That is, we do not want to take any extra array of n size. So how to do that? So for doing that, what we would do is, if you see, if we want to reverse the order of elements of this array, what we are actually trying to do is sending 9 to the last position and bringing the last element to the first position, right? So actually what we are doing is we are swapping the positions of last and first element. Similarly, if you see, the second element's position is getting swapped with the last but one's element position. So this 6 would be brought to last but one position, and this element 4 would be brought to second position. Similarly, 5 and 3's position are swapped. 5 is brought to the position of 3 and 3 is brought to the position of 5. And now for 1 there is no need of any swap, because this is a middle element. As the number of elements in this array is odd, the middle element would be spared. There is no need of doing anything with the middle element. If this number of swaps are done, so if the number of elements, total number of elements in the array is 7, and if 3 numbers of swaps are performed, we would accomplish our task, that is to reverse the elements of the array. So after this 3 swaps, the order of elements would be like this. 9 would go to the last position and 2 would be brought to the first position. 4 would come to second position and 6 would be at the last but one position. 5 would go to the last but two position. 3 would come to this position, and 1 remains as it was before, right? So this is the order of elements that we would get after these 3 swaps, and this is indeed the reversed order of elements with relation to the actual array, right? So 2 4 3 1 5 6 9, that is what we wanted to get. So we need to do 3 swaps if the number of elements in the original array is 7. What about if the number of elements, the number of elements in the original array is even? So if even number of elements are there, so say if there are 6 elements in the original array then the number of swaps that we need to do is still 3. So for 7 also we need to do 3 swaps, and for 6 number of elements also we need to do 3 swaps. What about 5? If the number of elements in the array is 5, then we need to do only 2 swaps, because the middle element would remain where it was already. So only 2 swaps would be required, whereas for 4 elements, that is if the number of elements in the array is 4, that is even, then only 2 swaps would be required, same as in case of 5 elements. So what we see is that if the number of elements is odd, then what we are doing is we are dividing this number by 2, and then we are taking a floor of it, right? Floor means an integer value which is just less than this fractional value. So if the number of elements is 7, 7 by 2 actually gives us 3.5, and if we take a ceiling of it, then 3.5, the number which is just lesser than 3.5 and its integer is 3. So the number of swaps that would be required in case of 7 is 3, and in case of even as well, if we take a ceiling, we would get actually the same thing. Whether we take a ceiling, sorry, if we take a floor, we would get the same thing. So if the even number is 6, 6 by 2 is 3. If we take a floor of it, it would give us the same answer, 3. If the odd number is 5, 5 by 2 is 2.5. If we take a floor, then the number of swaps that is required is 2. Similarly, if the even number is 4, number of elements in the array is 4, 4 by 2 is 2, and take a floor of it, it's 2. So the generic formula of number of swaps that has to be performed is this: number of elements of the original array divided by 2 and take a floor of it. Now let us go directly to the code and write this and code this solution. So first of all, I would just comment this out. So this is a multi-line comment, and as you know that the multi-line comment, this total block would be skipped by the compiler and it would not be converted into a machine code, right? So this is just for reference of the programmer. It would not be compiled and it would not be converted to machine code. So first of all, for this solution in which we are not taking an extra array, I declare a loop variable I, and as the number of elements in the original array is 6, so the number of swaps that would be required is 6 by 2, and then floor of it. So 6 by 2 is 3 and floor of it is of course 3. So starting from I equals to 0, if I need to iterate for 3 times, then the stopping condition can be put as I less than equals to 2, and the increment operation can be increment by just 1. Now what are the positions of the elements? Those are to be swapped. So 0th position has to be swapped with 5th position, right? And then first position has to be swapped with 4th position, and then second position has to be swapped with 3rd position. So this is the positions those are to be swapped. So for swapping 0th element with the 5th element, and then first element with the 4th element, and then second element with the 3rd element, the relation between the positions which are getting swapped is nothing but I and 5 minus I. So when I is 0, 5 minus I would give us 5. So 0th and 5 minus and 5 minus I, that is fifth position, are getting swapped. When I becomes 1, 5 minus I would give us 4. So first position and fourth position are getting swapped. When I becomes 2, 5 minus I would give us 3. So second and third position are getting swapped, right? So the position those are getting swapped is I and 5 minus I. So here you see we do not have any new array, any extra array. We are working on the original array only. So for swapping purpose, we would be using a temporary variable, and in temp we would first store the ith position of the array, element at ith position of the array, and after it is stored in temp variable, now we can assign to arr I the 5 minus ith position, element at 5 minus ith position of the array. At this point, temp would contain the ith element of the array, and the ith element of the array would have been overwritten by 5 minus ith element of the array. Now we would copy the element, the value that is contained in temp variable, to 5 minus ith position. So this is how we are going to interchange the elements of ith position and 5 minus ith position. So how this executes is, when I is 0, arr 0 gets stored in temp, and then 5 minus I, 5 minus, when I is 0, 5 minus I is 5, so arr 5 gets stored in arr 0. So fifth position gets copied to the first position. Now arr 5 minus I, that is arr 5, is equals to temp, and temp actually contains the element at arr 0. So 0th element getting copied to fifth position of the array. Now when I becomes 1, arr 1 getting copied to temp, then arr 5 minus 1, that is arr 4, gets copied to arr 1, and arr 4 into arr 4 we are copying the element, the value stored in temp, that is the value of arr 1. So when this for loop has run for 3 times, we have got the elements of the original array placed in reverse order. Now after this loop has run, what we can do is we can check by running this loop, whether by running a loop which would iterate through all the elements of the array and print it on the console. This is just to check whether we have accomplished our goal or not. So our goal was to reverse the element of the array. So if this has got accomplished or not, that we can check with printing all the elements of the original array. Now let us build it and see. So build is successful, and we have got 984652. So the original array was 256489 984652. 984652. So it has worked correctly. So with that we have finished with our solution, in which we didn't have to take an extra array of n size. Only handful of constant number of variables um, was enough for us. So the space complexity of this solution is order of 1, that is only constant number of variables were taken. So with that we have finished our program. Thank you for watching.